What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about the characteristics of wide area network services such as MPLS, ATM, frame relay, PPPoE, PPP, DMVPN, SIP trunk, in addition to learning about wireless area network terminations such as the demarcation point, CSU, DSU, and the smart jack. Now, I know it's a lot of acronyms in here, but the quicker you get to learn what these acronyms stand for, the better off you will be when it is time for you to take this exam. Let's talk about MPLS, and that stands for Multi-Protocol Label Switching. So MPLS, this is a routing technique in telecommunication networks that directs data from one node to the next based on short path labels rather than long network addresses, thus avoiding complex lookups in a routing table and speeding traffic flows. The labels identify virtual links, also known as paths, between distant nodes rather than endpoints, and MPLS can encapsulate packets of various network protocols, hence the multi-protocol reference on its name. And MPLS supports a range of access technologies, including T1, E1 circuits, ATM, frame relay, and DSL. Next, we have ATM, and that stands for asynchronous transfer mode. So asynchronous transfer mode, this is a telecommunications standard for digital transmission of multiple types of traffic, including telephony or voice, data, and video signals in one network without the use of separate overlay networks. ATM was designed to integrate telecommunication networks. It can handle both traditional high throughput data traffic and real-time low latency content such as voice and video. ATM provides functionality that uses features of circuit switching and packet switching network. It uses asynchronous time division multiplexing. In the OSI reference model, data link layer or layer number 2, the basic transfer units are generically called frames. In ATM, these frames are fixed length or 53 octets or bytes, and they are specifically called cells. This differs from approaches such as IP or Ethernet that uses variable size packets of frames. ATM uses a connection-oriented model in which a virtual circuit must be established between two endpoints before the data exchange begins. These virtual circuits may be either permanent, i.e. dedicated connections that are usually pre-configured by the service provider, or they can be switched, such as setting up on a per-call basis using signaling and disconnected when the call is terminated. Next, we have frame relay, and this is a standardized wide area network technology that specifies the physical and data link layers of digital telecommunication channels using a packet switching methodology. Originally designed for transport across ISDN or integrated services digital network infrastructures, it may be used today in the context of many other network interfaces. Network providers commonly implement frame relay for voice and data as an encapsulation technique used between LANs over a WAN. Each end user gets a private line or a leased line to a frame relay node. The frame relay network handles the transmission over a frequently changing path transparent to all end user extensively used WAN protocols. It's less expensive than leased lines, and that is one reason for its popularity. The extreme simplicity of configuring user equipment in a frame relay network offers another reason for frame relay's popularity. With the advent of Ethernet over fiber optics, MPLS, VPN, and dedicated broadband services such as cable modems and DSL, frame relay has become less popular in recent years. Then we have point-to-point protocol over Ethernet. So point-to-point protocol over Ethernet, this is a network protocol for encapsulating point-to-point protocol frames inside Ethernet frames. It originally appeared in the context of the boom of DSL in 1999 as the solution for tunneling packets over the DSL connection to the ISP's IP network, and from there to the rest of the internet. Typical use of point-to-point protocol over Ethernet involves leveraging the point-to-point protocol facilities for authenticating the user with a username and password. On the customer premises equipment, point-to-point protocol over Ethernet may be implemented either in a unified residential gateway device that handles both DSL modem and IP routing functions, or in the case of a simple DSL modem without routing support. Point-to-point protocol over Ethernet may be handled behind it on a separate Ethernet-only router or even directly on a user's computer. Let's talk about point-to-point protocol. So this is a a data link layer or layer 2 communication protocol between two routers without any host or any networking in between. It can provide connection authentication, transmission encryption, and data compression. Point-to-point protocol is used over many types of physical networks, including serial cable, phone links, trunk lines, cellular telephones, specialized radio links, ISDN, and fiber optic links. Since IP packets cannot be transmitted over a modem line on their own without some data link protocol that can identify where the transmitted frames start and where it ends, ISPs have used point-to-point protocol for customer dial-up access to the internet. Next, we have dynamic multi-point virtual private network. So DMVPNs, this is a dynamic tunneling form of a VPN supported by Cisco iOS-based routers, ARG3 routers, and on Unix-like operating systems. DMVPN provides the capability for creating a dynamic mesh VPN network without having to pre-configure all possible tunnel endpoint peers. Next, we have a SIP trunk. So SIP trunking is a voice over internet protocol or VoIP technology and streaming media service based on the session initiation protocol by which internet telephony service providers deliver telephone services and unified communications to customers equipped with SIP-based private branch exchange and unified communication facilities. Most unified communication applications provide voice, video, and other streaming media applications such as desktop sharing, web conferencing, and shared whiteboards. All right, let's talk about terminations. And the first one we're going to talk about is called the demarcation point. So the demarcation point, this is the point at which the public switch telephone network ends and connects with the customer's on-premises wiring. It is the dividing line which determines who is responsible for installation and maintenance of wiring and equipment, such as a customer, subscriber, or the telephone company / provider. The demarcation point varies between countries and has changed over time. Next, we have the CSU, DSU, or the Channel Service Unit, Data Service Unit. So a CSU, DSU, this is a digital interface device used to connect data terminal equipment, such as a router, to a digital circuit, such as a T1 line. The CSU, DSU implements two different functions. The Channel Service Unit is responsible for the connection to the telecommunication network, while the Data Service Unit is responsible for managing the interface with the data terminal equipment. A CSU, DSU can have an external connection point, or it can be integrated into a modular card installed in a router. A CSU, DSU is the equivalent of the modem for an entire LAN. The DCE, commonly a modem or CSU, DSU, this is the device used to convert the user data from the DTE or the data terminal equipment into a form acceptable to the wide area network service provider transmission link. And then we have a smart jack. So a smart jack, this is a smart and intelligent device placed right between the telephone company's demarcation and customer premises that performs connectivity checks and diagnostic tests. A very common capability provided by a smart jack is loopbacking, such that the signal from the telephone company is transmitted back to the telephone company. This allows the telephone company to test the line from the central office without the need to have test equipment at the customer site. All right, that is my quick little class. So let's go ahead and do some of this outstanding check on learning, shall we? So the first question is, which of the following enables VoIP calls between PBXs? Would it be VTP, PTSN, SIP trunks, or PPPoE? So which of the following enables VoIP calls between PBXs? And the correct answer is, that will be a SIP trunk or a session initiation protocol trunk. That is the correct answer. Next question. Which of the following devices would be used for connecting a router to a T1 line? Would it be a CSU, DSU, a media converter, an IDF, or an F-type connector? So which of the following devices would be used for connecting a router to a T1 line? And the correct answer is, this will be a CSU, DSU, also known as a Channel Service Unit, Data Service Unit. Next question. A remote line diagnostic device placed at the joining point between an ISP's line and customer premises wiring is known as what? Is this an OTDR, a line tester, a loopback adapter, or a smart jack? And the correct answer is, this would be a smart Jack, ladies and gentlemen. All right, so in summary, we have talked about all of this wonderful stuff as it directly relates to the characteristics of wide area network services. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.